This is the teacher summary for Lesson 2C, Proving Parallel Lines. We're going to start here in your Ringlet reference card. You want to turn to Lesson C now. Taking a look here, Proving Parallel Lines. When you're dealing with parallel lines, we also need to talk about angles of reflection. An angle of reflection is an angle that reflects off something. So it would be, for example, your image coming into this mirror and then reflecting off the mirror. That's called an angle of reflection. Let me turn this mirror sideways because there's something really important you need to understand about angles of reflection. If I'm looking at an angle this way, a mirror this way, and light comes in, and it's going to bounce off, of course, if this was a mirror, this is called the angle of incident, and this is called the angle of reflection, and they are congruent. When you have a physical mirror, or like still water on a pond, the angle of incident, the angle that light comes onto that surface, and the angle at which it bounces off that surface is congruent. That's called the angle of incident and the angle of reflection. If you've ever played billiards or pool, this is also true. When you shoot a cue ball and it bounces off the bumper and then it bounces this way and you're aiming for a pocket, this angle of incident is going to be the same as angle of reflection. So those who are really masters at billiards or pool actually are very good at angles and math. Now the question we're dealing with today is how can we assure lines are parallel, or how can we prove lines are parallel? And this is a really simple concept because it's simply the converse of what you learned the other day. The other day you learned if lines are parallel, alternate interior angles are congruent. The converse, or the switch of that, is also true. It says if alternate interior angles are congruent, then lines are parallel. So if you have a situation in which you have congruent alternate interior angles, also known as armpits of the Z, if those angles are congruent, it forces the lines to become parallel. Second one is if alternate exterior angles are congruent. That would be like angles 2 and 7. If they are congruent, then the lines are forced to be parallel. If corresponding angles are congruent, one's in, one's out, same side, if those are congruent, it forces those lines to be parallel. If same-side interior angles are congruent, then the lines, not congruent, but supplementary. So an angles like 4 and 6, if they add up to 180, they're on the same side of the transversal or stir stick, and between the lines, then the lines are parallel. Now there's a fifth one here. take a straight edge, please, to that line right there. Draw a perpendicular line. Put the right angle box there. And draw a second perpendicular line and put the right angle box. And you should notice, since these two green lines are perpendicular to the same line, yes, they are parallel. So that's the last way that you can prove a parallel line. If two lines are perpendicular to the same line, then the lines are parallel. Keep this cardstock right in front of you as you go to today's teacher summary example, which is right here. Keep that cardstock right in front of you, right underneath your nose. Okay, so it says, sweep and mark the given information. Then determine which lines must be parallel because of the given information and explain why those lines are parallel. A good chunk of your homework is going to be answering the question, why tonight, not just what the answer is. Okay, so let's start with A. It says angle SEF is congruent to RFG. So SEF, let's trace and sweep. I'm going to do this in blue. Angle SEF. So here we are, SEF, trace and sweep, is congruent to angle RFG. RFG, trace and sweep. So the question is, if those two angles are congruent, which lines are parallel? The trick to this is to figure out where your transversal is. Your transversal must be touching both of the involved angles, or I call it hugging or snuggled up against you, or however terminology you want to use. But if we're going to work with these two angles, there's only one line that qualifies as your stir stick. I'd like you to lay your stir stick down this way, or just darken it. Only that line qualifies as the transversal, because it's touching both lines. Now, ask yourself, which two lines is it cutting across? It's cutting across these two lines right here, which forces those two lines to be parallel, but now you have to ask why. And how you answer that is you ask yourself, what kind of angles are these? Look really close. One's inside the line, one's outside of the lines, same side. So one's in, one's out, same side. That would be corresponding angles. So they're corresponding angles. And in this case, they are congruent. So that forces those lines to be parallel. So we can say this. We know that this line right here, we're going to call that line AE, and this line BF are parallel. So AE segment and BF segment are parallel because corresponding angles are congruent. All right, let's try another set of angles. I'm going to use green this time, ABD and DFB. So let's do ABE, ABD, trace and sweep is congruent to DFG. So DFG, trace and sweep. Now looking at that, you ask yourself, what line are both angles hugging or snuggled up against or touching? Lay your stir stick down there, which you should notice, this is where it is. There's your stir stick right there. That's the only line that touches both of those angles. Now you ask yourself, which lines are being cut across because of those two angles? And we see these two lines are being cut across. Trace them. So we can see those two green angles are congruent. Now ask yourself, what kind of angles are these? Really important. What kind of angles are these? They're on opposite sides between the lines. Opposite sides between the lines. You should recognize those as alternate interior angles. Also known by me as armpits of the Z. And if that's the case, these two orange lines are parallel. Now you could use any two letters on these orange lines. I'm just going to go ahead and use these two inner letters here, which are going to be AB and EF. So I know in this scenario that line AB, or segment AB, it really doesn't matter at this point, is parallel to EF. And the reason is because of alternate interior angles are congruent. All right, let's do one more set here. Last one, we are told, what color have I not used? Let's use purple. That the measure of angle BAE, so let's trace BAE. BAE, so BAE, trace and sweep, plus the measure of FEA, so FEA, FEA. Now don't hatch mark these because we aren't told those are equal. Those two angles, they, however, add up to 180. So make a little caret here. These two add up to 180. So let's find our transversal. It's the single line that both angles are hugging. So lay your stir stick down or trace this line. That's your transversal, that's your stir stick. Now take a look at those two purple angles. They're on the same side and between the line. Same side between the line. Come up here, see if you can find a match. Same side between the line. They're called consecutive angles or same side interior angles. And they sum 180. So you ask yourself, which two lines do they cut across? And they're cutting across these two lines. Trace them. That means those two lines are parallel. I'm going to use these two inner points again. I could use TC if I wanted and EG. It doesn't matter. I'm going to go ahead and use AB again. So I know AB has to be parallel to EF. And the reason why is those are same side interior angles and they are supplementary. So same side interior angles are supplementary. Use this as a guideline for today's work.